Hello, in this video we're going to be looking at midsegments of triangles. So let's go ahead and start off with a triangle. And let's talk about what a midsegment is. Suppose you take the middle of one of your sides. So right here, let's suppose that that's the middle, and let's go ahead and label our sides. So A, B, C, those are our vertices. So if you take the middle of side AB and you take the middle of side BC, so right about there, and if you connect those two middles with a line segment, that line segment will be something called the midsegment. Now the midsegment is halfway up the triangle, and it has some pretty nice properties. Let's go ahead and call that midsegment DE. First property is that if you are given one of the measures, either AC or DE, either the bottom of the triangle or the middle of the triangle, you can always find the other length. And here's why. Suppose AC is 12. Then DE, since it is halfway up the triangle, it's going to be halfway or half that much, it's going to be 6. Likewise, if DE were 9, then AC would be twice as much. AC would be 18. So the bottom of your triangle, the base of your triangle, is always going to be twice as much as the midsegment. Or the midsegment will always be half the amount of the side length that's across from it. So 9 is half of 18. So here's an example problem. Suppose that JK is the midsegment of triangle FGH, and we're asked to find JK. Well, in order to find JK, we notice that JK, since it's the midsegment, it's going to be half as much as FG. Since FG was across from JK, JK is half of that amount. So half of 24 is going to be 12. In this example, we're asked to find the measure of PR, but we're not told that ST is actually the midsegment. We can figure that out by looking at the picture. Notice the two dashes on line segment PQ shows us that S is in the middle, and the set of double dashes on either side of point T tells us T is in the middle of RQ as well. So that means ST is the midsegment. So since ST is the midsegment and PR is across from it, PR is going to be 2 times ST. So that means it's going to be 30. So the measure of line segment PR is 30. And our last example in this video, we're asked to find the measure of LN. Again, notice TV is the midsegment and LN is across from it. That means LN is going to be twice as much as TV, or we could write that as x plus 12 will be twice as much as x plus 4. So again, the base equals 2 times the midsegment. So x plus 2 equals, let's distribute the 2. We get 2x plus 8. If we subtract x from both sides, we get 2 is equal to x plus 8. Excuse me, that should be x plus 12. And if we subtract 8 from both sides, we get 4 is equal to x. But we weren't asked to find the value of x. That just is going to be a middle step to actually helping us find the length of LN. Since x is equal to 4, we can substitute that in for x and get 4 plus 12, which is 16. So we're going to say LN is equal to 16, but it's always a good idea to check your work. If we put 4 in for x up here, 4 plus 4 is 8. So 8 is half of 16. That means LN equaling 16 is most likely our correct answer.